One of the new analysis capabilities of the MSO8000 series oscilloscope is the eye test or eye diagram application. We can use the eye diagram to measure complete signal quality, including looking at issues related to noise, timing, and bandwidth. Let's take a look at what an eye diagram is and how it helps us simplify debugging for complex signals, including serial data transmissions. Here we see our eye diagram test running on the MSO8000. We call this an eye diagram because of this shape here. What we want, ideally, for this data transmission is a nice open eye with an open space vertically and horizontally, allowing us to get very low error rate in our data transmission. This eye diagram is built with the high sample rate of 10 gigasamples per second and 10 million points. All those points are then correlated to the clock transition and then folded over on top of each other into a density display like this. That allows us to see how every transition looks compared to its clock point and the point at which we're actually calculating the data bit. We can actually see in this eye diagram there are a couple different issues impacting our results. One, we see vertically a lot of space here. This implies a certain amount of noise coming through the signal that might be affecting our ability to get a clear bit test at this point. Additionally, this rise and fall time on these transitions are pretty diagonal at about 45 degrees. In these settings, we'd like it to be steeper, giving us clearer corners in this eye diagram. That's likely a bandwidth issue, not allowing the signal to change fast enough. And we have a certain amount of frequency noise causing this to move back and forth left to right and causing this distribution here. So we're using the histogram to look at the crossing pattern and show us the distribution of those transitions. Now that we've identified the issues in this eye diagram, we went ahead and started to debug the problem. The first problem we found was the signal that was causing the amplitude noise. So we've been able to remove that, isolate that crosstalk, get rid of it, and reduce our noise on all of these signals. So now we can see how these signals are separated, the top layers, and we're starting to open the eye a little bit. Now we can clearly see that there's a bandwidth issue, keeping these signals from rising all the way to the top and falling all the way to the bottom transition levels. We still see a little bit of frequency noise, but clearing up the amplitude noise has helped us a lot. Now let's see if we can solve that bandwidth problem. After making some changes to our transmitter design as well as our cabling, we've been able to considerably increase that bandwidth. We now see with the same settings, the slope is much faster on both the rising and falling edges, giving us a much more open eye area. Combination of removing the noise, improving the bandwidth, has also really limited the total frequency and jitter noise as well. Now we have a nice open eye that allows us to go ahead and push our throughput by increasing our data rate if we need to really maximize the effectiveness of this serial data transmission. So those are the ways that eye diagram testing and a histogram can really help you to complete your signal analysis and signal fidelity measurements by looking at noise, bandwidth, and timing across a complete deep memory cut of measurements and serial data. By overlaying that data from the deep memory into a density plot for easy visualization, the MSO8000 makes eye diagram testing easy.